But we have already explained or illustrated quite a few ways to convert a series of cash flow into a different series of cash flow, or even a single value at different time. So those are ways that we can get economic equivalence of different series of cash flow. However, during the process, you probably had the feeling that the interest rate that we use will influence the outcome significantly, right? Because the time value of the money is captured by the interest rate. When you have a larger interest rate, you can imagine that the speed of change will be much faster. So at that point, looking into the future, then the difference will be much bigger. However, adding to the complexity is in the real world, when we are looking at the interest rate, sometimes for the business reason, sometimes for just to give a very simple way of a simple or intuitive way of a number, people create different terms to describe different interest rate. If we don't know that, we don't know their differences, we cannot convert them into the kind of interest rate that we need to use, then we cannot correctly compute the equivalence. So that is what we are going to discuss in this chapter. That is, when we are given a number of the interest, what does that mean? Is it the real interest that we have in mind? Is it the real interest that brings us from one point to another point, helping us to convert a certain cash flow to another set of cash flow correctly? The answer at this point will be no, because some are just a way to describe a very limited usage of the interest rate. Whenever you want to use it for more complicated cases, you need to convert the interest rate into the kind of interest rate that reflect the problem that we have. In particular, we're going to talk about nominal and effective interest rates. That will be the key part, and we'll show different ways of conversion into different so-called effective interest rates, so that we can use the rate to compute the kind of cash flow that we need to compute. And there are more details that we can share, so that you get a better sense of the effect of effective interest rate by different variation. So typically, or in many cases, you have heard of this term, nominal interest rate. Nominal interest rate. Nominal interest rate in some case can be equal to effective interest rate, but in most of the other cases, nominal rate will not be the same as effective interest rate. When we say effective interest rate, you can imagine that we are talking about the interest rate that really provide us the effect. It helps us to convert cash flow based on its time value precisely. The nominal interest rate is just a specification of the rate for a year. It's talking about quotation of the rate for a year. However, it has many possible ways that we will use the rate. So whenever we get quoted with nominal rate, if we want to compute effective interest rate, we need to go through a series of conversion. Sometimes within a year will be charged many times, right? Charged many times. So the rate will be used for many. The rate, interest rate, will be used or computed many times within a year. But if we assume that for a year we will only be charged once, that will be our nominal interest rate and also the effective interest rate. If we have 1 year of nominal rate, but however when we are charged for the interest, we will be charged multiple times within a year, then we need to compute the effective, the true interest rate for smaller period within a year. Also, we need to compute the true effective interest rate for the entire year. So in order to compute effective annual interest rate, we can utilize the following equation. Suppose the effective annual interest rate is represented by I sub A, which is to the left of the equal sign, and to the right you can see that they are basically R, which represents nominal interest rate, okay, which will be the interest rate that is quoted for the interest for a year. However, in this particular case, within a year, we will be charged with the interest many times, meaning that within a much shorter period of time, we will be charged for the interest. Then it will happen recurrently within the year. So intuitively, if you think of it, when we are charged much earlier than at the end of the year, then you will be charged already, and your principal plus your interest, the interest you owe, you will become your principal. Then you will be charged again. So within that period, if there is an effective rate for that period, then you need to compound them many times before you reach the duration of the year. So if you think of it, you will probably have guessed that your annual effective annual interest rate will be bigger than the nominal interest rate, because you will be charged a lot faster within the course of a year, a lot more frequent, so that if you compound them, you can guess that it will probably be bigger. So what we can do is we will take the nominal rate R and divide it by the number of interest periods per year within that year. So M could means that, oh, if we want to charge, if we want to compute the interest monthly, then within a year there are 12 months. So R will be divided by 12, and to the nth power and minus 1, then you will get our effective annual rate. If we are doing this weekly, then we'll have 52 periods, interest period within the year. So M will be equal to 52. So R will be divided by 52, and again to the nth power, which will be 52. Okay, so we can change the number of interest periods within the year. Then we'll have different instantiation of the value in the equation, and we can come up with different effective annual interest rate. Okay, it was quite straightforward, and you can probably also guess that as the number of interest periods increased, okay, as the number of interest period increased and the power increased, so chances are the value, the effective annual interest rate will grow. Right? As the number of interest period increase, the value of the effective annual interest rate will grow accordingly. Let's look at an example. Here we have a nominal rate of 18%, and the way that we reference the interest periods will be compounded with some period. So here we said that with 18% of the nominal interest rate, we will compute. They will be compounded monthly, meaning that we will accrue interest every month. Okay, so since it's monthly, remember how we said previously, we want to compute the equivalent interest rate. It will be 18% divided by 12, because 1 year, every year we have 12 months. So we got 0.015. Okay, 0.015 here, and we will take the power of 12, the 12th power, and we can use this to compute the effective interest rate. In this case, it is 19.56%. So meaning that if we were quoted 18% of nominal interest rate, and we want to know its actual interest rate for the year, which is the effective interest rate, effective annual interest rate, it turns out to be 19.56%, which is larger than 18%. Okay, I can also see from the figure here, right? We divided, because we charged this 18% compounded monthly. We just divide 18% into 12 parts. Each part is 1.5%, and we will charge 1.5% of interest every month. So this principle will be changing as time goes, and with a bigger and bigger base, and in the end we will accumulate more interest than what 18% nominal rate can represent. So so we can say that with the 18% of the nominal rate compounded monthly, it's equivalent to we have 1.5% of the interest per month for 12 months. So these two all give us the same effective annual interest. Okay, both of them will come out to 19.56% effective annual interest rate. Right, they are equivalent interest. Right, their effective interest rate or effective interest will be identical. They were just described differently, using different way of saying it. So 18% compounded monthly, when it becomes 18% compounded weekly, then we need to compute the effective rate for each week. We can come up with an interest too. And these two statements will again be the same. So we can look at this table and think of what we have already done just now with different nominal rate. Here we have nominal rates spanning from 4% to 12%, and with the nominal rate equal to if the interest was compounded annually, the nominal rate and the effective annual interest rate will be identical. Because compounded only once, there won't be this compounding effect. But if we compound them semi-annually, you can see the difference immediately. As we continue to have finer compounding period, as you can see that the effective annual interest rate continue to grow. However, as it becomes finer and finer, then the increment of the effective interest rate gets smaller. Okay, so here, because 4% is probably too small to see the difference. If we take 12%, right, compounded annual interest rate will be 12%. When you come to compounded semi-annually or compounded quarterly, monthly, daily, you can see the difference. Okay. However, again, as I said, the finer it is, the marginal increment of the interest rate is getting smaller, is diminishing. Okay. So yeah, later we'll want to see will this continue refinement of the interest period converge or whatever things it will happen. Okay, but now at least you see that the effect is the effective annual interest rate will not be the same as the nominal interest rate, and depending on the interest period, then the values will be different. But when it's finer, meaning with smaller period of time that you will already charge the interest, then the value will continue to grow. However, the growth will become smaller and smaller. You can also look at this simple example to see how that happened. And we have 9% nominal interest rate compounding quarterly. So when we want to compute effective annual interest rate, what we'll do is we'll take this 9% and divide it into 4, right? Because we have 4 quarters in 1 year. So for each quarter, the effective interest rate will be 2.25. So we'll start from the first quarter. We have the base amount, which is 10,000, and you will get interest from the 2.25 interest rate, and that becomes your principal, 10,225. So for second quarter, again, you will get this 2.25 interest rate, and you get its corresponding interest based on your new principal, 10,225. So the interest become bigger than 225, and you continue doing that for the rest of the 2 quarters. In the end, you get 10,930 and 0.83. Okay, so you accumulate your interest and allowing the interest becoming your principal, and continue to calculate the new interest. Okay, that is the actual interest that you will get, and that should be at least the 2.25 are 2.25 is the effective interest rate for the quarter. However, people will ask, what will be the effective annual interest rate. Again, here we can easily compute, right, based on the equation previously.